So if we have multiplication as repeated addition, and then similarly division as repeated subtraction, what if we wanted to do repeated multiplication? You may have seen this before. You may have not. I'm not going to go too in-depth. There's going to be whole lesson videos about exponents and whatnot. Oh, spoiler alert. Exponents. That's what it is. Exponents, for those who haven't really worked with this just yet, you can kind of loosely think of it as repeated multiplication. I'm going to first kind of define what an exponent is using letters so it can work in general. So we have x raised to the a power, and that equals y. I think for vocab words I'm going to put it in red. So vocab, x, which is the base. When we refer to the base of an exponent, it's the number that's being repeatedly multiplied by itself. We have a, which is itself the exponent, and then y is just the outcome of it. How about this? Yeah, that's not very formal, but this is the idea. The base is the number that is going to be multiplied by itself a certain amount of times. The exponent is how many times we multiply the base by itself. So for instance, if I wanted 2 to the third power, this is not the same thing as 2 times 3, because that's multiplication. Multiplication is repeated addition. Exponents are repeated multiplication, so they're not the same thing. What this means is, based off of this stuff, we're going to take 2 and multiply it by itself 3 times. So it's 2 times 2 times 2, which is 8. And this is the basics for exponents. There is an opposite of exponents, but we'll cover that much later. I just want you to get familiar with raising natural number constants to natural number exponents. There is one other thing when it comes to operations: parentheses, brackets. The parentheses aren't really an operation. It keeps an order of preference. So when I have 2 plus 3 plus 4, I want to do the thing inside the parentheses first. That's all that means. I can't really add 4 to a thing. This is kind of like holding these guys back. You can't touch these guys until you've done everything you can inside of them. So then you would go 2 plus 3 is 5, and then 5 plus 4 is then 9. So it's not an operation itself, it's just telling you which operations in a problem that you want to do first. There is a special type of parentheses, which I'm sure you've seen before, called absolute value. The bars kind of look like just long lines like this. And then we'll put some number inside. I'll say 3. Whatever's inside the absolute value bars, kind of like with the parentheses, you do everything you can inside the parentheses. Then when you've kind of got it down to a number like this, whatever's inside the bars, make it positive. And then that is enough to resolve the absolute value bars, so they just go away. So it becomes 3. So if I were to ask you what's the absolute value of -3, you would say, okay, whatever's inside, make it positive. So it's positive 3. I'm sure you've heard of this explanation of it before, but the reason behind the absolute value is that if we were to go back to the number line, what the absolute value of a number is telling you is its distance from 0. So if I were to go like 1, 2, 3, the distance from 3 to 0 is 3 ones, three units. That distance is 3. Then we similarly can go to -3, and I were to be like, well, what's the distance between -3 and 0? Well, realistically, you don't think of distance as negative. That doesn't really make any sense. Like, you could stand and then walk backwards, but you're still going a certain distance in that direction. So you can never really have negative distance. So when you're working with absolute value, you just want to know how far it is away from 0, which is still 3. We are going to be working with full equations and such with the absolute value, but probably not until we start doing quadratics, because they work very similarly.